Okay. So usually I write down the objectives, but there's only one objective in this lesson. It's to simplify a rational expression. And that's all we're doing today. So I want you to circle this word, though. The word rational. Rational means fraction. So we're going to be dealing with expressions that are in the form of fractions. Okay? So I write this. It's more than just a fraction like 1/2 or 5/11. Those are fractions. A rational expression is slightly different. So write this down. Rational expression equals a polynomial divided by another polynomial. That's a rational expression. So it's still in the form of a fraction, but it's not just a number divided by a number. It's an expression divided by an expression. Like this one here, x squared plus 2x divided by x minus 4. That's a rational expression. Okay? And we're going to learn how to simplify those, and it's really easy. Let's go back, though, to your 4th grade year of elementary, maybe even 3rd grade. I don't know when it is you learned about simplifying fractions, but we got to go way back. Let's review how to simplify. I know you all know how to do this, and you're pretty good at it, but I want to go back to the very basics and make sure you understand what you were really doing. Okay? Hopefully, most of you could just look at that and say, oh, yeah, that's 2/3. No big deal. Okay? But what are we really doing to get 2/3? That's what you need to understand. So I want you to write this. 8 is 4 times 2, 12 is 4 times 3, and we're going to break that down even more into 2 times 2 times 2 divided by 2 times 2 times 3. You guys okay with what I've done so far? Move it. This? Okay. That's called the prime factorization. 8 is 2 times 2 times 2 because they're all prime numbers. 12 is 2 times 2 times 3. Okay. I want you to draw arrows to these. I know you know this, but I want you to write it anyway. Those are called factors. Factors multiply together. If you're adding a bunch of things up, those aren't called factors. If you're multiplying a bunch of things together, those are called factors. Okay? What you guys are really doing when you're simplifying fractions is you're crossing out common factors. This 2 right here, on the top and bottom, they cross out. These 2's cross out. You can cross out or cancel out common factors. Cross out common factors. So all you guys that simplify fractions, this is really what you're doing in your head. Kind of cool, right? You're canceling out common factors without even knowing it. But here's what you can't do. And I know you guys know this with numbers, but when we start doing expressions like this thing up here, then a lot of funky things start happening that aren't mathematical. So let's start again with 8/12. Couldn't I write this as 7 plus 1 over 11 plus 1? Isn't that still true? Can I cross out those ones?
Yeah.
Like I crossed out these 2's and I crossed out these 2's, but I can only cross out common factors, and factors multiply together. These are not factors. 7 plus 1, those aren't factors of 8. 11 plus 1, those aren't factors of 12. You cannot cross out those ones right here. Okay? If you have terms that are separated by plus or minus signs, you can't cross out parts of those terms. This right here doesn't work. And I know you guys know that with numbers, But once we start getting variables, then students start trying to do weird things like that. It just doesn't work. We good so far? Let's start looking at some expressions then. Open up your books to page 144.
144. Run right to it. No, you did. Wow, that's pretty cool. All right, anyway. We're on 3.1. Okay. Actually, I think we should go to 146. Yeah, 146.
So, let's start example 1. And we're going to use the problems out of this book. So the first problem there, part A, is 21a to the second power divided by 7a to the third. The directions are to simplify. Bless you. (21a squared over 7a cubed). You're going to get to the point, at least I hope some of you get to the point where this is going to go much faster than what I'm about to show you. But for right now, this is what I want to see. Okay? 21a squared, I want to expand that. 21 is 3 times 7, and then a squared is a times a. I want you to write that all out, just like that. 3 times 7 times a times a. This is the prime factorization. Isn't this just like what I showed you with numbers? Now we're just doing it with variables and numbers. What about 7a to the third? That's 7 times a times a times a. They're all separated by multiply signs. That means we can cross out common factors now. So this a crosses out, those a's cross out, the 7's cross out. So we're left with 3 over 8. That's how you simplify rational expressions. That's your answer. Okay? Now, look carefully, though, at the directions. Somebody read them to me. What are the directions? Simplify. And then what else? There we go. That's also pretty easy, but we can't forget about that. So write this. Simplify and state what are called excluded values. Bless you. This is the simplified form right here. So that answers that part of the question. Simplify. No, that's a good idea. That's a good thought, but not what we crossed out. Excluded values are things that a cannot equal. You guys know we can't divide by 0, correct? So if you go back to the original form right here, you always go back to the original form to state excluded values, not the simplified form. If you go back to the original function or the original expression, what if I plugged in a 0 for a? What would happen if I plugged in a 0 for a?
You get a 0 on the bottom, right? Are we okay having a 0 on the bottom? No. So that's your excluded value. A cannot equal
0. So you would say, all right, a cannot equal 0. That's all you do. Why can't a equal 0?
It would make the denominator equal 0, which is no good. You can't divide by 0. So you would state the simplified form, which is 3 over a, and then you state the excluded value, which is a cannot equal 0. That's all. Okay?
Questions on that one? Let's do the second one there, part B. 18 d squared over 4d plus 8. Here's what a lot of students try. I want you to stop writing for just a second. I see a lot of students do this. Well, there's a d here that can cancel with that d right there. Big problem. What's the problem with that?
There's a plus sign before d plus 8. You can't cross out things that are separated by plus signs. Only if they're separated by multiplication. There's a plus sign right after that d. You can't mess with that d.
So that's not going to work. So let's go back. We have to write this out in factored, in expanded or factored form. 18 is 2 times 3 times 3 That's 18. D squared is D times D. We gotta be careful on this one. 4D plus 8. We're not actually going to be able to write it as just a bunch of things multiplied together. What factors out of 4D plus 8? What can we take out of that? We can't take out a 2. We can, but there's something bigger we can take out besides a 2. Let's take out a 4. Yep. And then I want to go one step further. Again, as you guys get better at this, you might not have to do all of these steps. But I want to change this 4 into 2 times 2 times D plus 2. Now you need to try your hardest to listen very carefully and try to understand this. This D plus 2 now is a factor, just like all of these others. 2 and a 3 and a D, those are all factors. This D plus 2 counts as one factor. Even though it's 2 terms, it counts as one factor. Why? Because 2 times D plus 2, they're all multiplying together now. You follow? So this has been fully factored. Now we can start crossing out common factors. Is there anything in common? The 2's here. So you can cross out those 2's. What about this D and this D right here? No, you cannot cross out part of a factor, only the entire factor. So that's all we can do. The answer is going to be 9D squared over 2 times D plus 2. That's as far as it goes. Okay? So that's the simplified form. Now we have to state the excluded values. So you go back to the original right here. And it doesn't matter what the numerator is. It only matters what the denominator is. You got to think a little more carefully here. What can't D equal?
Negative 2. Why is it negative 2? What's 4 times negative 2? Negative 8 plus 8 is 0. So you can't have 0.
So your excluded value is D cannot equal negative 2. Now, I don't expect you guys just to be able to come up with that number. Some people can, okay? But the real way that you ought to do this is, all right, if we're trying to find the excluded values, you take the denominator, set it equal to 0, and just solve that easy equation. If you subtract 8, you have 4D equals negative 8. And then if you divide by 4, you get D equals negative 2. That's your excluded value. D cannot equal that. Okay? Still easy, right? Let's try part C. 2n minus 3 over 6n minus 9. Oh, changed her mind. Am I that intimidating? So 2n minus 3, is there anything that can factor out of 2n minus 3? Besides 1? Anything besides 1 that can? No, there's nothing to factor out of 2n minus 3, so that stays the same. But 6n minus 9, there's something that can come out of that. 3, so take out a 3. And what? Look at that. You remember how I said you can't cross out parts of a factor, but you can cross out an entire factor as long as there's another factor that matches it? Remember I said that? Well, here we have a 2n minus 3 factor, and on the bottom we have a 2n minus 3 factor. Those cross out. Okay. You got to be careful, though. The answer is not 3, because 3 is in the denominator. It's 1 over 3. Yeah? And that's the simplified form. So now I have to do excluded values, so I'm going to take this denominator here, 6n minus 9. 6n minus 9 equals 0. What's going to make that equal 0? Well, if you add 9 over, you make 6n equals 9. Divide by 6, which which is 9 over 6, but you want to simplify that. N equals, come on now. Okay, you can write it like that if you want. I would just write it as, I would just write it as 3 over 2, and that's what n cannot equal. Make sure you put a slash through that. N cannot equal 3/2. That's your excluded value. All right. I'm going to speed this one up here a little bit. This is taking a little too much time. 26c to the third plus 91c divided by, those are big giant numbers, 2c squared plus 7. Now, denominator, take a look at the denominator. They both don't have c's, so you can't factor out a c. And does 2 go into 7? No. There's nothing you can factor out of the denominator. But if you look at the numerator, they both have at least one c, so you can factor out a c. And then 13 goes into both 26 and 91, so you can factor out a 13c. And guess what that leaves you with? If you take a 13 out of 26, you get 2. C squared, and then 13 divided by 90, or 91 divided by 13 is 7. Those cancel. So the simplified form is 13c. Now put your thinking caps on here for a second. We have to state the excluded values. So we need this 2c squared plus 7. If you're clever enough about this, you can just skip this next step. If you're clever enough about this. Okay? We're trying to find out what c can't equal. Okay? Now, I want you guys to put on your imaginations here. If I plugged in a negative number for c, and then squared it, what happens to that negative number? If you square a negative number, it comes out positive. And then if I take that positive number and multiply it by 2, it's still positive. And if you add 7, so that's not going to equal 0. Is there any negative number I could plug in here and square it and then multiply it by 2 and then add 7 that's ever going to equal 0? What about any positive number? Can I plug in any positive number, square it, multiply by 2, add 7, and have that ever equal 0? Is this ever going to equal 0? Okay. So let me show you something else. That might have gone a little over some of your heads. If we tried to solve this, we would get this, right? And then if we divided by 2, we would get this. But then what would we have to do? And then you'd have to square root. So c equals plus or minus square root of negative 7/2. What happens when you square a negative? It's imaginary. Imaginary numbers don't count as excluded values. Since that's imaginary, there are no excluded values. Okay. And it's because 2c squared plus 7 is always going to be something that's positive. It's never going to be 0, and it's also never going to be negative. There's no excluded values. So real quick, I want you guys to try down to the bottom of page 146. Try those 2 problems on your own. Problem number 1, problem number 2. You can do it as part of your notes if you want.
Doesn't have to be on a separate sheet of paper, but do problems 1 and problems 2.
The first problem you were supposed to do, 4x to the third over 28 x to the fourth. You guys watch carefully. I saw a lot of you do some good things in there. I saw some of you still a little bit confused. So you need to break down the numbers especially into the smallest numbers you can. 4 is 2 times x times x times x. Okay? 28. I know it's 4 times 7, but 4 can be broken down into 2 times 2 times 7 times x times x times x times x. What's that? 28 is 2 times 2 times 7. Okay? That x crosses out, those x's cross out, those x's cross out. The 2's and the 2's cross out. So we're left with 1 over 7x. Okay? And then the excluded value, if you go back here and look at that denominator, what can't x equal? X cannot be 0. You have to state the excluded value. Okay? Question 2, we had 3x squared minus 9x over x minus 3. Okay? If you have a minus or a plus sign between terms, you can't just write it like something like this where everything's multiplying together. You've got to factor out something. So if you look at this, 3x squared minus 9x, they have the 3x in common. You can factor out a 3x. Okay? And that's going to leave you with x minus 3. And then the denominator just stays x minus 3. So now what? The whole entire x minus 3 factor crosses off with that x minus 3 factor. And you're left with 3x. Now the excluded value has to come from here. X cannot be 3. Okay? So a lot of your homework problems are going to look like this. It does get a little, I'm not going to say more challenging, but it gets different. Let's do one more example, example 2, then we better call it quits. Example 2. So this is on page 147 now, part A. We're doing 2x minus 8 divided by x squared minus 2x minus 8. This is what I meant by if you're good at factoring, these assignments aren't going to be that tough. Because you're going to have to do a lot of this kind of factoring here. I am. So you can watch me here. So let's start. 2x minus 8, the numerator, what do they have in common? 2x minus 8. 2. That leaves x minus 4. This denominator has to be factored differently because it doesn't have a common factor for all 3. Okay? This is where you're going to end up with something that looks like this. 2 parentheses multiplied together. Okay? So you, if not already, you need to become very good and very quick at this kind of factoring because you learned it last year in secondary 2 and we've practiced it for like the last 3 weeks in secondary 3. Okay? If you know still that you're struggling with factoring, you don't just say, oh, well, I'm never going to get it. You go in and get help from the math lab. Okay? If you know where your problems are, go fix them. Okay? So the way that you do this factor is you multiply the first number by the last number. 1 times 8 is, or negative 8 is negative 8. We need factors of negative 8 that add to negative 2. So here we go. Negative 1 and 8, or 1 and negative 8. Do those add to negative 2? No. What about negative 2 times 4 or 2 times negative 4? Any of those work? That add to negative 2? Which one? 2 and negative 4. So then, and this is the way I have always showed you every single time, once you know the 2 numbers, you're going to split that middle term into those 2 numbers, 2x minus 4x. And this is just factor by grouping. So what comes out of this first group? Be careful. What do they both have in common? They don't both have x squared. They both just have an x, and that leaves you with x plus 2. From the second group here, you want to take out the biggest number that you can. So we're going to take out a minus 4, and that leaves x plus 2. And you look, hey, we have an x plus 2, and here we have an x plus 2. That means one of your parentheses is x plus 2. If they both match, that's one of your parentheses. The other parentheses are these two numbers that factored out, x minus 4. So the x minus 4 factors cancel out. The simplified form is 2 over x plus 2. Now we need the excluded values though. Okay? I wouldn't go back to the original. I would go back to right here. The factored form of the original. We haven't crossed anything out yet. Take a look at this factor and this factor. We're going to get two excluded values now. So let's focus on one at a time. From just this factor, what shouldn't you plug in for x? So x cannot equal 4. And the other one is going to be x should not equal negative 2. Both of those excluded values come from the factors of your denominator. Okay? So that's what your next set of homework problems look like, is there's just a little bit more involved factoring. I actually lied to you. There's one more we need to look at. Sorry. Example 3. Then we're done. They're going to try to throw you off with something like this. I want to see if you guys can figure it out. I'm going to give you a minute to look at that. I bet some of you in here can figure this one out. Don't just say, well, I'm going to wait for him to show me. You guys don't form any new ideas, and you don't get any smarter if you just watch other people do things for you. Okay? Think. Use your brains.
Like, I know it doesn't right now, because I know you have to.
So, you can't cross off parts of a factor, right? Like I can't cross off just that and just that. You understand that? Okay, but don't they look pretty dang close to being almost exactly the same? They're not exactly the same. I would make a suggestion here. Maybe this will help spur some ideas. Rewrite the denominator as this. Have I changed anything yet?
All I did is switch the terms around. Now I want you to look at that. You guys are smart enough, I'm sure some of you can figure this out.
From where? Did you guys hear that? That's all it is. If I factored out a negative 1 from the denominator, what do we get? 2x minus 5, which matches what we have in the numerator, 2x minus 5. See, I knew some of you in here could figure this out. You're close. So now those are gone, the 2x minus 5s are gone, and you're right, we have 1 over negative 1, which is just negative 1. Now we need the excluded value, so you go back to the original and say, all right, 5 minus 2x, what's going to make that equal 0? It's not that hard to solve, you guys. This is a simple 7th grade equation. Come on now. What do you do? What's the next step? Add the 2x over. Divide by 2. So x cannot equal 5/2, and that's the simplified form. So there you go. It really doesn't seem that bad, does it? Next time's assignment, when you come back, is a lot like this one. It's about as easy.